Okay, now for the fun part. What we're going to learn in this video is how to use these reference angles that we just learned how to find those exact values of trig ratios. So in other words, how to skip doing the whole memorize the unit circle and just use triangles instead. So what I'm going to do is I'm going to come over here to the examples and do one for you. And then we're going to go back and we're going to talk about the how to. Okay. So in order to do this, you are going to need, and I'm going to draw them up here just so we have them. You're going to need your two special triangles. Okay, so remember the 45, which I'm going to label as pi over 4, 45, 90, and the 30, 60, 90. Okay, so again, I'm going to draw these up here for reference. You're going to use these so many times. So this would be the 60, which is pi over 3. This would be the 30, which is pi over 6. Now, remember we learned them as and A root 2. But then when we did the whole like opposite over adjacent, the A's canceled. And so you just had 1 over 1. So what we're going to do, I mean, A could be any number. So we're going to actually kind of re-memorize these with A just being 1. So I'm going to call these sides 1, 1, and root 2. And then that would make these sides between the 60 and the 90 was A, so that'll be 1. The hypotenuse was 2A, so that'll be 2. And the side between the 30 and the 90 was A root 3, so it'll just be root 3. These two triangles will get you through all of the unit circle memorization that you needed. Okay, so if you memorize just these two triangles, then you can put them down on a piece of paper and you can find the sine of pi over 3 or the tangent of pi over 6. You can do any sines, cosines, secants that you need just from these two triangles. Okay. The only other piece of information I'm going to apply is the all students take calculus so that I can remember if I'm in a quadrant that's not the first quadrant, which of my ratios is positive, negative, etc. Okay, so let's start with finding the exact value of the sine of 210. Okay, so what I'm going to do is I'm going to look at 210. Where is that? And the more you do this, the faster you get. So 210 is in this quadrant right here, and its reference angle is 30 degrees. Okay. So what I'm going to do is I'm going to look at 30 degrees in my triangle, which is the pi over 6, and I'm going to find the sine of that. The sine of this is opposite over hypotenuse. Oops, opposite over hypotenuse. This is the hypotenuse. So that would be 1/2. But because I'm in the third quadrant, sine is negative. And you're done. So what I'm essentially doing, the part I didn't draw, and you could have made this 30, 60, 90 triangle right here, which would have made this side root 3, this side 1, this side 2. And then you could have gone to, okay, opposite over hypotenuse, and then made sure you took account the sine, or you could have even called this side negative and this side because they're both a negative x and a negative y. So you're using the reference angle and essentially a reference triangle to identify the trig ratio. But I will go as far as long as I can just find the reference angle, then I can look at the triangles not necessarily graphed in the correct quadrant and apply the correct sign, and I'm good to go. Pretty cool, huh? Let's do one in radians, and then we'll go back and read the instructions. So 5 pi over 3. Remember, 3 pi over 3, 6 pi over 3. So 5 pi over 3 is going to be right here, and its reference angle is pi over 3. Pi over 3. Oh, I'm looking for secant. So instead of doing adjacent over hypotenuse, I'm going to do the reciprocal of that, hypotenuse over adjacent. but I'm in the fourth quadrant. In the fourth quadrant, cosine and its reciprocal, which would be secant, are positive. So my final answer here will just be 2. Again, I could have dropped this down, filled in my sides. That's not the right side. So here's the one place you do need to be careful. This is the square root, or sorry, this is pi over 3 and this is 90. Pi over 3 to 90, that side is 1. And my root 3 is over here. Clearly I didn't draw this to scale. So I could draw in the whole triangle in that place if I wanted to, but it's not necessary. Do remember, if you draw in the triangles, the x's and the y's could be negative. So in this case, this would have been a negative because the y is down, but the hypotenuse is always considered positive. All right, so let's go back to the instructions that I have written out here and make a little sense of them. How to use reference angles to find exact values of trig ratios. So draw the angle in standard position, find the measure of its reference angle, and if necessary, if you want to, draw its triangle. You don't necessarily have to if you have the triangle already referenced. Okay. Assuming the reference angle is a special angle, in other words, 30, 45, or 60, pi over 6, pi over 4, pi over 3, fill in the sides of the reference triangle using the special triangle relationship. So in other words, just make the A 1. You can label the sides with the plus or minus if you want to, depending on the quadrant, or you can just use the terminal quadrant sign data that all students take calculus. And then you just use that triangle and its sign to answer the question. Okay. Now, one quick note, if your reference angle at the end of step 1 is not a special angle, then you're going to have to use your calculator. You can't do this unless your reference angle is 30, 60, or 45. Okay, so I already have all of these things written here for you. Why don't you pause the video and try number 3 and number 4. Okay, so starting with cosine of 3 pi over 4. 3 pi over 4 is in the second quadrant. Its reference angle is pi over 4. So if I come back up here, cosine of pi over 4 is 1 over root 2, but I'm in the second quadrant, and that would make it negative. So negative 1 over root 2, which is the same as negative root 2 over 2. 11 pi over 6 is here in the fourth quadrant. Its reference angle is pi over 6. I'm looking for cotangent this time. So I'm going to find my pi over 6. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. Root 3, but I'm in the fourth quadrant. So cotangent is negative. Be careful. That C stands for cosine, not cotangent. So I literally will just make a note card with these two triangles and this plus the unit circle with the, the 0, pi over 2, pi, 3 pi over 2, those coordinates there. And that's all I need to answer any questions. And then I'm also connecting things with triangles, which is what trigonometry is based on. Nothing wrong with memorizing the unit circle. I particularly find when I teach calculus that the students who have memorized the unit circle really struggle with understanding the concepts of trigonometry, and instead have just tried to shove like the numbers that they need to spit out into their brain. And it ends up causing some conceptual issues down the line, particularly in Calc 2. If you have to take Calc 2, you have to be very well versed in the triangle aspect of trigonometry. It comes back with a vengeance. So that's why I try to teach trig in this way, so that people can kind of connect the meaning of what they're doing with their processes.